Hello there and welcome to the Sleepy Science channel. I'm so glad you found your way here tonight. Maybe you've had a long day filled with deadlines and decisions, or perhaps you're simply the kind of person who finds comfort in drifting off to sleep while thinking about things far greater than ourselves, distant stars, ancient light, the quiet turning of cosmic wheels. Either way, tonight's journey is designed just for you. We're going to explore our home galaxy, the Milky Way, together. Not with urgency or pressure, but slowly, gently, like tracing constellations with your finger on a cool summer night. Tonight, we'll wander through 100 fascinating facts about the galaxy we call home. You won't need to remember them all. In fact, you don't need to remember any of them. This isn't a test or a lesson with stakes attached. This is simply an invitation to let your mind float among the stars while your body settles deeper into rest. Some of these facts may surprise you. Others may feel like old friends returning. All of them are here to guide you softly towards sleep. So go ahead and get comfortable, adjust your pillow. Pull your blanket a little higher if you'd like. Let your shoulders drop away from your ears. There's nothing you need to do right now except listen, and even that can be as light as you want it to be. If you drift away halfway through, that's perfect. If you make it all the way to the end, that's wonderful too. There's no wrong way to experience this. Before we begin, if you enjoy falling asleep to gentle science facts and cosmic wonder, consider subscribing to this channel. Give the video a quiet like if it feels right. But truly, the most important thing is that you're here now, ready to let the universe rock you gently to sleep. So take a slow breath in, let it out even slower, and let's step together into the starlight. Our journey begins with something almost too vast to fully grasp. Our Milky Way Galaxy is home to somewhere between 100 billion and 400 billion stars. Imagine that for a moment. Not 100, not 1,000, but hundreds of billions of burning suns, each one a distant point of light, perhaps with its own family of planets, its own story unfolding across time and space. When you look up at the night sky and see what appears to be a river of soft light stretching overhead, you're seeing just a fraction of those stars, the ones close enough and bright enough for your eyes to catch. The rest remain hidden, not because they're absent, but because they're simply too far away, their light too faint to reach you clearly. Yet they're there, burning quietly in the dark, contributing to the gentle glow of our galactic home. There's something deeply calming about that, isn't there? All those stars just existing, doing what stars do, without needing recognition or applause. Just being. Just shining. And speaking of vastness, the Milky Way stretches approximately 100,000 light-years from one edge to the other. To put that in perspective, light, the fastest thing in the universe, racing through space at about 186,000 miles per second, would need 100,000 years to cross from one side of our galaxy to the other. If you sent a beam of light on that journey around the time humans first started painting on cave walls, it would only just be arriving on the far side now. Our galaxy is so spacious, so generous with room, that even light needs millennia to traverse it. And yet, from the outside, if you could somehow step back and view the Milky Way from a distance, it would appear as a delicate spiral, graceful and almost fragile, like a cosmic flower suspended in the void. There's a kind of poetry in that contrast, something so enormous it humbles comprehension, yet so elegant it could make you weep. Our galaxy isn't flat like a dinner plate, though it may seem that way in pictures. It has thickness too, about 1,000 light-years at its thinnest points, and bulging to roughly 12,000 light-years thick at its central core. Imagine a fried egg, if you will, with the yolk representing that dense, crowded center where stars pack together more tightly, and the white representing the flatter disk where most of the spiral arms unfold. This shape formed over billions of years as gravity pulled matter inward and rotation flattened it outward, creating a structure that balances the inward collapse with the outward spin. When you think about it, our galaxy is like a dancer frozen mid-spin, holding a pose that's been sustained for eons. And we live within that pose, tucked into one of the quieter arms, rotating along with everything else, part of a choreography so slow and vast we barely notice we're moving at all. At the very heart of our galaxy, approximately 26,000 light-years from where we sit right now, there exists something both terrifying and strangely peaceful, a supermassive black hole called Sagittarius A star. This cosmic giant contains roughly 4 million times the mass of our Sun, all compressed into a region smaller than the orbit of Mercury. It doesn't rage or scream. It doesn't announce itself with fire or fury. It simply exists, warping space and time around itself so intensely that not even light can escape once it crosses a certain threshold. Yet despite its immense power, it sits relatively quietly at the center of our galaxy, anchoring everything, providing the gravitational focus around which hundreds of billions of stars orbit. In some ways, it's the still point at the center of a turning world, or in this case, a turning galaxy. There's something almost meditative about that, a reminder that even the most powerful forces in the universe can exist in a state of quiet presence. Our Sun, that familiar star that warms your face on summer afternoons, is just one small part of this galactic family. It orbits around the center of the Milky Way at a speed of about 514,000 miles per hour. That might sound impossibly fast, but given the sheer size of the orbit, nearly 26,000 light-years in radius, it takes our Sun approximately 230 million years to complete just one lap around the galactic center. Astronomers sometimes call this period a cosmic year or a galactic year. The last time our Sun was in this same position in its orbit, dinosaurs hadn't yet appeared on Earth. Tiny reptiles were just beginning to diversify. The next time it returns here, who knows what Earth will look like, or if anyone will be here to mark the occasion. There's a strange comfort in realizing how small our human timescales are compared to these vast cosmic rhythms. Our worries, our deadlines, our anxieties, they're all held within a much larger context, one where time moves differently, more slowly, with infinite patience. And here's something that may shift your perspective just a little bit more. Our entire solar system, sun and planets and all, is moving through space not just in its orbit around the galactic center, but also bobbing up and down through the galactic plane like a carousel horse gently rising and falling. We cross through the thickest part of the Milky Way's disk roughly every 30 million years or so, then climb above it, then sink below it, then cross through again, tracing a wave-like path through the stars. Right now, we're currently on the northern side of the galactic plane, slowly making our way back toward the center region. This gentle bobbing motion means that our view of the galaxy changes ever so slightly over millions of years, like slowly walking around a sculpture and seeing it from different angles. We're not static observers. We're participants in a cosmic dance that unfolds over timescales our minds can barely touch. And that's okay. You don't need to understand it fully. Just knowing it's happening can be enough. The Milky Way isn't actually milky, of course, though the name has stuck with us for thousands of years. Ancient Greeks saw that band of light across the sky and called it Galaxias Kyklos, meaning milky circle, because it reminded them of spilled milk. The Romans called it Via Lactea or Milky Way. Other cultures have their own names. The Chinese called it the Silver River. Nordic peoples saw it as a path to the halls of the gods. And many indigenous cultures around the world have woven it into their creation stories and seasonal calendars. What we're actually seeing when we look at that pale band stretching across a dark sky is our galaxy from the inside, edge on, looking through the disk toward the denser regions filled with distant stars. Their combined light, softened by dust and distance, creates that gentle glow. It's like being inside a snow globe and trying to see through all the tiny flakes to the other side. The view is dim and diffused, but no less beautiful for it. In fact, there's something tender about seeing your home this way, from within, imperfectly, through a veil of cosmic dust. Our galaxy is classified as a barred spiral galaxy, which means it has a central bar-shaped structure made of stars, and from the ends of that bar, spiral arms curve outward like water swirling down a drain or cream stirred into coffee. There are 4 major spiral arms: Perseus, Sagittarius, Centaurus, and Cygnus, though the exact number is still debated because it's surprisingly difficult to map a structure when you're living inside it. Imagine trying to draw a map of your house while standing in one room with no windows. You'd need to piece together clues, measurements, indirect observations. That's what astronomers do with our galaxy. They use everything from the motion of stars to the distribution of gas clouds, slowly building a picture of the Milky Way's shape. And what they've found is something elegant, a cosmic pinwheel turning slowly in the dark, each arm trailing with young blue stars, glowing nebulae, and vast clouds of gas and dust where new stars may one day be born. We live in one of these arms, the Orion Spur, a smaller branch between 2 larger arms, tucked into a relatively quiet neighborhood. The stars in our galaxy aren't all the same age. Some are ancient, nearly as old as the universe itself, while others were born only a few million years ago, which in cosmic terms is practically yesterday. The oldest stars, often found in the galactic halo and in globular clusters that orbit the Milky Way like distant moons, can be around 13 billion years old. They formed when the universe was still young, made primarily from hydrogen and helium because heavier elements hadn't yet been forged in stellar furnaces. These elder stars are often smaller, redder, cooler, and they carry within them the memory of a younger cosmos. Meanwhile, in the spiral arms in regions like the Orion Nebula, stars are being born right now, massive, hot, blue-white stars that burn bright and fast, living intensely for only a few million years before ending in spectacular supernovae. The Milky Way is not a static museum. It's a living gallery where birth and death happen continuously, where generations of stars overlap, and where the building blocks of life itself are forged and scattered back into space to begin again. Between the stars, filling the space we might imagine as empty, there exists something called the interstellar medium, a thin soup of gas and dust that makes up about 10 to 15% of the Milky Way's visible matter. It sounds like nothing, just empty space with a few stray atoms drifting around, but this medium is crucial. It's the raw material from which new stars are born. When regions of this gas and dust grow dense enough, gravity begins to pull them together, compressing them until temperatures rise, nuclear fusion ignites, and a star is born. The interstellar medium also contains complex molecules: water, alcohol, sugars, amino acids, chemicals that hint at the building blocks of life scattered throughout the galaxy like seeds in a cosmic wind. In some ways, the space between stars isn't empty at all. It's a nursery, a workshop, a slow-motion garden where the elements that make up planets and people alike drift and gather, waiting for gravity to pull them into something new. You could say we're made of stardust, and you'd be right, but you could also say we're made of the space between stars, the quiet, patient darkness that holds everything together. Our galaxy also has a halo, not the kind you see in paintings of saints, but an enormous, roughly spherical cloud of matter that surrounds the visible disk and extends perhaps 600,000 light-years or more from the galactic center. This halo contains old stars, globular clusters, and something else we can't see directly: dark matter. In fact, most of the halo's mass comes from dark matter, a mysterious substance that doesn't emit, absorb, or reflect light, but whose gravitational effects can be measured and felt. Scientists estimate that dark matter makes up about 85% of the matter in the universe, and much of the Milky Way's total mass comes from this invisible halo surrounding us. It's humbling, isn't it, to realize that the galaxy we can see, the stars, the gas, the glowing nebulae, is just a small fraction of what's actually there. The rest is hidden, dark, silent, pulling on everything with invisible strings. It's a reminder that reality is often more than what we can touch or see, and that mystery isn't something to fear, but something to sit with quietly, like the darkness in your room right now as you listen to these words. Speaking of dark matter, the rotation of our galaxy provides some of the strongest evidence for its existence. When astronomers measure how fast stars orbit the galactic center at various distances, they find something unexpected. Stars farther outmove faster than they should if only the visible matter, stars, gas, dust, were providing the gravitational pull. According to the laws of physics, the outer stars should be moving more slowly, like planets farther from the Sun orbit more slowly than those closer in. But they don't. They move at speeds that suggest there's far more mass in the galaxy than we can see, distributed in that vast halo around us. This invisible mass, the dark matter, provides the extra gravity needed to hold the galaxy together and explain the rotation curves. Without it, galaxies like ours would fly apart, their stars flung into intergalactic space by the speed of their own orbits. So in a very real sense, we owe our existence to something we cannot see, something that holds us gently in place without asking for recognition. It's the universe's quiet backbone, the unseen foundation beneath everything we know. The Milky Way didn't always look the way it does now. Billions of years ago, it was smaller, less organized, a rough gathering of gas and dark matter slowly collapsing under its own gravity. Over time, it grew by merging with smaller galaxies that wandered too close, absorbing them, adding their stars to its own collection. This process is called galactic cannibalism, though the term sounds more violent than the reality. When galaxies merge, their stars almost never collide. Space is so vast that even when two galaxies pass through each other, the stars slip past like ghosts, their paths altered by gravity but rarely resulting in actual impacts. What does happen is a slow, graceful blending, a cosmic dance that takes hundreds of millions of years to complete. Some of the stars in our galaxy today were once part of other, smaller galaxies that were consumed long ago. They carry with them faint traces of their origins, slightly different chemical compositions, unusual orbits like accents in a language that hint at distant homelands. And this process isn't over. The Milky Way is still growing, still consuming, still evolving. It's not a finished product. It's a work in progress, just like you. One of the most dramatic chapters in our galaxy's future has already been written, or at least predicted. In about 4 billion years, the Milky Way will collide with our nearest large galactic neighbor, the Andromeda Galaxy, currently located about 2.5 million light-years away. Andromeda is moving toward us at roughly 68 miles per second, and this approach is inevitable. When the collision happens, and collision is perhaps too harsh a word, as it will be more like a slow interpenetration, the two galaxies will pass through each other, their stars rearranging, their structures warping and stretching, eventually merging over the course of several billion years into a single, larger galaxy. Astronomers have already given this future galaxy a name, Milkomda, a blend of Milky Way and Andromeda. By the time this merger completes, our Sun will likely have left the main sequence and swelled into a red giant, rendering Earth uninhabitable. But the galaxy itself will continue, transformed, reborn into something new. There's something almost comforting about this long view, the reminder that change is woven into the fabric of everything, that endings and beginnings are often the same moment seen from different angles, and that the universe continues its story regardless of individual fates. Our galaxy is not alone in the universe. It's part of a small collection of galaxies called the Local Group, which contains more than 50 known galaxies, though most of them are small, faint dwarf galaxies that orbit the two dominant members, the Milky Way and Andromeda. Other notable members include the Triangulum Galaxy, the Large and Small Magellanic Clouds, which are visible from the southern hemisphere as fuzzy patches of light, and a handful of tiny satellite galaxies with names like Draco, Sculptor, and Fornax. These smaller galaxies orbit the Milky Way much like moons orbit a planet, held by gravity, their stars slowly being pulled away over billions of years by tidal forces. The Local Group itself is just one small neighborhood in a much larger structure called the Virgo supercluster, which contains thousands of galaxies spread across tens of millions of light years. And even that supercluster is just one thread in an even vaster cosmic web, a universe-spanning network of galaxy clusters and filaments separated by enormous voids. We're nested within layers of structure, each one larger than the last, like a set of cosmic matryoshka dolls. It's dizzying if you think about it too hard, but right now, you don't need to think hard at all. Just let the idea wash over you. You're part of something unimaginably large, and that's okay. The center of our galaxy is a crowded, chaotic place. Stars there are packed so closely together that the night sky, if you could somehow stand on a planet near the galactic core, would be ablaze with thousands of stars brighter than Venus appears to us, casting shadows and filling the darkness with a perpetual twilight glow. The density of stars near the center is millions of times greater than in our neighborhood. If you lived there, neighboring star systems might be only a fraction of a light year away, close enough that interstellar travel, if it were possible, would take far less time than it does in our sparse region of the galaxy. But that region is also dangerous, in a way. The intense radiation from so many stars, the gravitational chaos, the risk of close encounters that could destabilize planetary orbits, it's not a calm place. Here, out in the Orion Spur, about 26,000 light-years from all that intensity, we live in what might be called the galactic suburbs, quiet, stable, with plenty of space between neighbors. It's a good place for life to take root and slowly evolve over billions of years without too much interference. Sometimes the best seats aren't in the center of the action. Sometimes they are on the edge, where you can watch the show from a safe, comfortable distance. The Milky Way isn't static. It rotates, but not like a solid wheel. Different parts rotate at different speeds, a phenomenon called differential rotation. The inner regions spin faster than the outer regions, which means the spiral arms aren't permanent structures made of the same stars over time. Instead, they're density waves, regions where stars, gas, and dust temporarily pile up as they move through their orbits, like cars slowing down in a traffic jam. As material moves into a spiral arm, it compresses, triggering star formation, which is why the arms often glow with young, bright stars and colorful nebulae. Then the material moves out the other side, and the arm remains behind, waiting for the next wave of matter to pass through. It's a beautiful, dynamic process, more like a wave rolling across the ocean than a fixed structure. This means the spiral arms you see in images of galaxies like ours are temporary patterns, shapes drawn in starlight that shift and change over millions of years. The galaxy is constantly repainting itself, never quite the same from one epoch to the next, always in motion, always becoming. And motion is a theme we can't escape when talking about the Milky Way. Not only is our galaxy rotating, but it's also moving through space as a whole. Relative to the cosmic microwave background, the faint afterglow of the Big Bang that permeates all of space, the Milky Way is traveling at about 1.3 million miles per hour toward a region of space in the direction of the constellation Hydra. Astronomers call this direction the Great Attractor, a massive concentration of mass located about 150 million light-years away that exerts a gravitational pull on our local group and many other galaxies in this region of the universe. We're all being drawn toward it slowly, like leaves drifting toward a drain. But this motion is so gradual, so smooth, that we don't feel it. There's no cosmic wind in your face, no sense of acceleration. Just a quiet, patient drift through the darkness, part of currents and flows that span distances our minds can barely process. And somehow, that's deeply relaxing, to know we're moving, always moving, carried along by forces much larger than ourselves. And we don't have to steer or decide. We're just along for the ride. Within the Milky Way, there are structures older than almost anything else in the galaxy, globular clusters, spherical collections of stars that formed early in the universe's history. These clusters can contain hundreds of thousands or even millions of stars packed into a region only a few hundred light-years across, which is incredibly dense compared to the spacing of stars in our neighborhood. There are about 150 known globular clusters orbiting the Milky Way, most of them in the halo, following long, elliptical orbits that take them far above and below the galactic plane before swinging back again. The stars within these clusters are ancient, often more than 10 billion years old, their light a faint, reddish glow that speaks of ages past. If you could visit a planet within a globular cluster, the night sky would be stunning beyond imagination. Thousands of stars visible to the naked eye, some close enough to show as disks rather than points, the darkness nearly banished by their collective light. These clusters are like time capsules, preserving a record of the galaxy's youth, and studying them helps astronomers understand what the Milky Way was like in its infancy. They're reminders that some things endure, that even in a universe defined by change, pockets of stability can persist for billions of years, quiet and patient, waiting to tell their stories. Our galaxy is full of clouds, not the fluffy white ones you see on summer afternoons, but vast clouds of gas and dust called nebulae. Some are bright and colorful, lit up by nearby stars whose ultraviolet light excites the gas and makes it glow in shades of red, pink, blue, and green. These are called emission nebulae, and they're often regions where new stars are being born, stellar nurseries where gravity is pulling matter together into dense knots that will eventually ignite into fusion. Other nebulae are dark, appearing as silhouettes against the background light of the galaxy, dense enough to block the light from stars behind them. These dark nebulae, like the famous Horsehead Nebula or the Coal Sack, are composed of thick dust and gas, cold and quiet, waiting for some disturbance, perhaps a nearby supernova or the gravitational nudge of a passing star, to trigger their collapse into new star systems. And then there are reflection nebulae, which don't glow on their own but simply reflect the light of nearby stars, appearing blue because dust scatters shorter wavelengths more effectively, the same reason our sky is blue. These nebulae are the Milky Way's paintbrush strokes, adding texture and color to the canvas of space, proof that the galaxy is not just a collection of points of light, but a living, breathing artwork in constant creation. One of the most famous and visually stunning objects in our galaxy is the Orion Nebula, located about 1,350 light-years away in the constellation Orion, easily visible to the naked eye as a fuzzy patch in the sword hanging from Orion's belt. This glowing cloud is one of the closest and brightest star-forming regions to Earth, a place where new stars are being born right now. Within it, astronomers have identified young stars only a few 100,000 years old, some still surrounded by disks of gas and dust that may eventually form planets. The nebula glows with the light of 4 massive young stars at its heart, known as the trapezium, whose intense ultraviolet radiation ionizes the surrounding gas and makes it shine. Observing the Orion Nebula is like watching a cosmic nursery in action, seeing the process that formed our own sun and solar system playing out in real time, just on a much larger and more luminous scale. It's a reminder that creation is ongoing, that the universe is not finished with making stars and worlds, and that even now, new chapters are being written in the story of the Milky Way. There's something hopeful about that, something that invites you to imagine futures yet unfolding, possibilities not yet realized, stories waiting to be told. Stars in our galaxy come in many varieties, but one of the most intriguing are the red dwarfs, small, cool stars that make up about 70% of all stars in the Milky Way. These stars are tiny. Some have less than 10% of the sun's mass, and they burn their hydrogen fuel so slowly, so conservatively, that they can live for trillions of years. That's far longer than the current age of the universe, which means every red dwarf that has ever formed is still alive today, quietly glowing in the darkness, and will continue to do so long after stars like our sun have burned out and faded. Red dwarfs are the ultimate survivors, the torches that will keep burning long after nearly everything else has gone dark. In the far, far future, when the universe is old and cold and star formation has ceased because all the available gas has been used up, red dwarfs will be the last stars shining, the final embers of a universe slowly winding down. There's a bittersweet beauty in that image, these small, humble stars outlasting the giants, the bright ones, the stars that blazed with glory but burned out fast. It's a reminder that sometimes the quiet ones, the ones who don't demand attention, are the ones who endure. At the opposite end of the stellar spectrum are the hypergiants and supergiants, stars so large and luminous they defy easy comprehension. Consider a star like Betelgeuse, a red supergiant in the constellation Orion, roughly 650 light-years away. If you placed Betelgeuse where our sun is, its surface would extend beyond the orbit of Mars, swallowing Mercury, Venus, Earth, and Mars whole. It's a dying star nearing the end of its life, and when it finally exhausts its fuel, it will explode in a supernova so bright it may be visible during the day from Earth, casting shadows at noon for weeks or even months. But that explosion, whenever it happens, whether tomorrow or in the next 100,000 years, will also be an act of creation. The blast will scatter heavy elements forged in the star's core into space, seeding the interstellar medium with carbon, oxygen, iron, gold, uranium, all the building blocks of planets and life. Every atom in your body heavier than hydrogen was created in the core of a star, or in the explosive death of one. You are made of the remnants of stars that died long before the sun was born, their ashes gathered into new clouds, new systems, new chances at complexity. In a very real sense, you are stardust given shape and consciousness, the universe looking back at itself with wonder. The Milky Way is also home to some of the most energetic and mysterious objects in the cosmos, neutron stars and pulsars. When a massive star explodes as a supernova, Its core may collapse into an object only about 12 miles across, but containing more mass than the Sun, compressed so tightly that a sugar cube-sized piece of neutron star material would weigh about 1 billion tons on Earth. These objects are so dense that their gravity warps spacetime dramatically, and their magnetic fields are among the strongest in the universe. Some neutron stars spin incredibly fast, hundreds of times per second, emitting beams of radiation from their magnetic poles that sweep across space like lighthouse beams. When those beams point toward Earth, we detect regular pulses of radio waves or light, and we call these objects pulsars. The precision of these pulses is extraordinary. Some pulsars keep time more accurately than atomic clocks, their rotation so stable that they can be used as cosmic timekeepers. There's something almost comforting about that, knowing that out there in the galaxy, scattered among the stars, there are these reliable beacons, pulsing steadily, marking time with unwavering consistency, cosmic metronomes ticking away the eons. In a universe that often feels chaotic and unpredictable, pulsars are small islands of regularity, proof that even in the aftermath of violent death, order can emerge. You're doing beautifully. There's no need to hold onto every detail, no pressure to remember names or numbers. Just let the words wash over you like gentle waves on a shore, each one carrying you a little closer to sleep. Notice your breathing, in and out, slow and steady. Your body knows what to do. It knows how to rest, how to let go. The galaxy will still be there tomorrow, spinning quietly in the dark, patient and timeless. For now, just drift, just float. Let the stars hold you. The Milky Way contains planets, so many planets that the number is almost meaningless. For every star in the galaxy, astronomers now believe there may be one or more planets on average, which means there could be hundreds of billions of planets orbiting stars within our galaxy alone. Some are gas giants larger than Jupiter, others are rocky worlds like Earth, and still others are exotic types we don't have in our own solar system, super-Earths, mini-Neptunes, lava worlds, ice giants, rogue planets drifting through interstellar space without a star to call home. Among all these worlds, statistical estimates suggest there could be tens of billions of planets in the Milky Way located in their star's habitable zone, the region where temperatures might allow liquid water to exist on the surface. Liquid water is considered essential for life as we know it, which means there could be billions of places in our galaxy where life might arise, evolve, and perhaps even develop intelligence. We don't know yet if any of them have. The search continues, but the sheer scale of possibility is staggering, humbling, and in a strange way hopeful. We may not be alone. Somewhere out there, on a world circling a distant star, under a sky filled with unfamiliar constellations, perhaps someone else is looking up and wondering the same thing. One of the most exciting discoveries in recent decades is the confirmation of thousands of exoplanets, planets orbiting stars beyond our Sun. The first confirmed exoplanet orbiting a Sun-like star was discovered in 1995, and since then, thanks to missions like Kepler and TESS, astronomers have identified more than 5,000 confirmed exoplanets, with thousands more candidates awaiting verification. These worlds come in astonishing variety. Some orbit their stars so closely they complete a year in just a few Earth days, their surfaces molten and hellish. Others drift in the cold outer reaches, dark and frozen. A few are eerily similar to Earth in size and temperature, orbiting quiet red dwarf stars, and these are the ones that excite astrobiologists the most. Worlds where conditions might be just right for life to take hold. Each discovery is a small miracle, a reminder that the Milky Way is not a sterile collection of rocks and gas, but a galaxy teeming with worlds, each one unique, each one a potential stage for stories we can barely imagine. And we've only just begun to explore. The galaxy is large, and our technology is still young. There's so much more waiting to be found. Among the many wonders of our galaxy, few are as poetic as binary star systems, pairs of stars that orbit each other, bound together by gravity, dancing around a common center of mass. More than half of the stars in the Milky Way are thought to be part of binary or multiple star systems, which means the single, solitary sun we orbit is somewhat unusual. Imagine standing on a planet in a binary system, watching two suns rise and set, their combined light painting the sky in strange and beautiful ways, casting double shadows, creating sunrises and sunsets unlike anything we experience on Earth. Some binary systems have stars so close together they exchange material, gas streaming from one star to the other, spiraling inward in glowing accretion disks. Others are widely separated, each star almost independent, only gently tugging on the other over vast distances. And then there are contact binaries, where two stars are so close they touch, sharing a common envelope of gas, essentially two hearts beating within one body. These systems challenge our notions of what a star is, what a star system can be, and they remind us that partnership and connection aren't just human concepts, they're woven into the fabric of the cosmos itself. The Milky Way is filled with light we cannot see. Visible light, the rainbow of colors our eyes detect, is just a tiny sliver of the electromagnetic spectrum. Our galaxy also glows in infrared, radio waves, ultraviolet, X-rays, and gamma rays, each wavelength revealing different aspects of the galactic ecosystem. Infrared light penetrates dust clouds that block visible light, allowing us to see into the hearts of star-forming regions and peer toward the galactic center. Radio waves let us map the distribution of hydrogen gas, tracing the spiral arms and the galaxy's large-scale structure. X-rays reveal hot, energetic phenomena, supernova remnants, the superheated gas around black holes, the coronae of active stars. Gamma rays, the highest energy light, come from the most violent events, pulsars, black holes, and possibly even the annihilation of dark matter particles. To truly see the Milky Way, we need more than our eyes. We need telescopes tuned to every part of the spectrum, each one peeling back another layer of invisibility, revealing hidden worlds within worlds. It's a bit like listening to a symphony where you can only hear one instrument. Adding more instruments doesn't just make it louder, it reveals the depth, the harmony, the full richness of the composition. The galaxy is a symphony, and we're learning to hear all of it. Within our galaxy, there are structures called stellar streams, long, thin trails of stars stretching across the sky, remnants of dwarf galaxies and globular clusters that have been torn apart by the Milky Way's gravity. As these smaller systems orbit the galaxy, tidal forces pull them apart, stretching them into elongated streams that can span thousands of light years. These streams are like cosmic fossils, markers of past collisions and mergers, evidence of the Milky Way's long history of growth through consumption. By studying these streams, astronomers can map the distribution of dark matter in the galaxy, because the paths the streams take are influenced by the invisible mass surrounding them. It's detective work on a cosmic scale, piecing together the history of violence and transformation that shaped the galaxy we see today. But even in that history of destruction, there's a kind of beauty. Those torn-apart galaxies didn't disappear. Their stars still shine, now part of a larger whole, woven into the fabric of the Milky Way. Nothing is truly lost. Everything is transformed, recycled, given new context and new meaning. Even in endings, there are beginnings. Our galaxy has weather of a sort. Not the rain and wind we experience on Earth, but vast flows and currents of gas, shock waves from supernovae, winds blown off massive stars, and energetic outflows from the supermassive black hole at the center. These phenomena shape the interstellar medium, compressing gas here, dispersing it there, triggering star formation in some regions while quenching it in others. Supernova explosions, for example, blast shells of gas outward at speeds of thousands of miles per second, creating expanding bubbles that can persist for millions of years, their edges glowing faintly as they plow into surrounding material. These bubbles can trigger the collapse of nearby clouds, leading to the birth of new stars, death giving rise to life in an endless cycle. Meanwhile, the galactic center occasionally burps out jets and bubbles of high-energy particles, inflating enormous lobes above and below the galactic plane, structures called Fermi bubbles that stretch for tens of thousands of light years. We don't fully understand what causes them, perhaps periodic feeding frenzies of the central black hole millions of years ago, but they're there, glowing faintly in gamma rays, a reminder that even the heart of the galaxy has a dynamic, active past. The Milky Way is not a still life. It's a living system, breathing, churning, evolving, constantly reshaping itself in response to the forces playing out within it. Light from the most distant parts of the Milky Way takes tens of thousands of years to reach us, which means when we look at those regions, we're seeing them not as they are now, but as they were in the distant past. This is true of everything in astronomy. The farther away something is, the further back in time we're seeing it. When you look at a star 100 light years away, you're seeing light that left that star around the time your great-great-great-grandparents were born. When you look toward the galactic center, you're seeing light that left 26,000 years ago during the last ice age on Earth, when woolly mammoths still roamed and humans were just beginning to create art on cave walls. In a sense, the Milky Way exists across time as well as space. We can never see it all at once, as it truly is in this moment. We only ever see a collection of different moments, layered together, a galaxy that is as much a timeline as a place. There's something quietly profound about that, time and space woven together so tightly they become inseparable. And we, small and brief as we are, sitting within that weave, trying to make sense of it all before our own light fades. Among the strangest objects in the Milky Way are the black holes, not just the supermassive one at the center, but smaller stellar mass black holes scattered throughout the galaxy, the remnants of massive stars that ended their lives in supernova explosions. When the core of such a star collapses and no force can stop the compression, it collapses past the neutron star stage into something even more extreme, a black hole, a region of spacetime where gravity is so strong that not even light can escape. The boundary of this region is called the event horizon, and crossing it is a one-way trip. Anything that falls in, matter, energy, information, is lost to the outside universe forever, at least according to our current understanding. Yet black holes aren't cosmic vacuum cleaners, indiscriminately sucking up everything nearby. They're only dangerous if you get very close. From a distance, a black hole's gravity is no stronger than the star it replaced. If the Sun were suddenly replaced by a black hole of equal mass, Earth's orbit wouldn't change at all, though we'd certainly freeze in the dark. Black holes are patient. They wait. They don't chase. And in their silence, in their utter darkness, they represent perhaps the most extreme environment the universe can produce, a place where the normal rules break down and the fabric of reality itself is bent into shapes we're still struggling to comprehend. There are stars in the Milky Way moving so fast they will eventually escape the galaxy entirely. These are called hypervelocity stars, and they're traveling at speeds exceeding the galaxy's escape velocity, over 1,000,000 miles per hour in some cases. How do stars reach such incredible speeds? Often, it's the result of a close encounter with the supermassive black hole at the galactic center. If a binary star system wanders too close, one star may be captured by the black hole, while the other is flung outward like a stone from a slingshot, accelerated to tremendous speeds by the gravitational interaction. These runaway stars are now on trajectories that will take them out of the Milky Way and into the intergalactic void, destined to spend the rest of their lives in the darkness between galaxies, isolated and alone. It's a melancholy thought, but also a kind of freedom. Those stars are no longer bound by the gravity of their home, free to wander wherever the universe takes them. In a way, they're explorers, even if unintentional ones, carrying light into the cosmic wilderness. And who knows? Perhaps billions of years from now, one of those stars will find a new galaxy to call home, pulled in by gravity, beginning a new chapter in a new place. The Milky Way's spiral arms are lined with regions of intense star formation, often marked by giant molecular clouds, immense reservoirs of cold hydrogen molecules, where the raw material for new stars is concentrated. These clouds can be hundreds of light years across and contain the mass of millions of suns. Within them, small pockets of gas collapse under their own gravity, fragmenting into smaller and smaller clumps until eventually, the cores grow hot enough for nuclear fusion to begin, and stars ignite. This process doesn't happen in isolation. When one massive star forms and begins emitting intense ultraviolet light and strong stellar winds, it can compress nearby gas, triggering the formation of more stars in a cascading effect. And when that first massive star dies in a supernova, the shock wave can trigger even more star formation. It's a self-perpetuating cycle. Star formation begets more star formation, clusters of young stars lighting up entire regions of the galaxy, turning molecular clouds into glowing stellar nurseries. This is how the Milky Way renews itself, how it ensures that even as old stars die, new ones are born to take their place, keeping the galaxy alive and luminous across the eons. One of the most visually striking features of our galaxy, when viewed from the outside, would be the dust lanes, dark ribbons of interstellar dust that trace the inner edges of the spiral arms. These lanes are where dust grains, tiny particles of carbon, silicon, and other elements, are densest. The dust absorbs and scatters light, making these regions appear dark against the brighter background of stars. But this darkness is misleading. The dust isn't empty or lifeless. It's actually a critical component of star formation, providing surfaces where molecules can form and shielding the interior of molecular clouds from disruptive radiation, allowing them to remain cold and dense enough to collapse into new stars. Dust also plays a role in planet formation, tiny grains sticking together to form pebbles, pebbles colliding to form boulders, boulders aggregating into planetesimals, and eventually, planets. Without dust, the Milky Way would be a very different place. So the next time you think of dust as something to clean away, something unwanted, remember that in the galaxy, dust is essential. It's the foundation of creation, the quiet enabler of complexity and life. Darkness and dust are not obstacles. They're beginnings. Throughout the Milky Way, there are also variable stars, stars whose brightness changes over time, pulsing, flickering, or dimming in regular or irregular patterns. Some of these variations are intrinsic, caused by processes within the star itself. Cepheid variables, for example, pulsate rhythmically, expanding and contracting, their brightness rising and falling in periods that range from days to months. The period of a cepheid's pulsation is directly related to its intrinsic brightness, which makes these stars incredibly useful as standard candles for measuring cosmic distances. By observing how bright a cepheid appears and knowing how bright it actually is, astronomers can calculate how far away it is with impressive accuracy. Other variable stars are eclipsing binaries, where two stars orbit each other in such a way that, from our perspective, one passes in front of the other, causing a periodic dip in brightness. Still others are eruptive variables, stars that suddenly flare or change brightness due to instabilities or interactions with companion stars. Each type of variable tells a story, reveals something about stellar physics, and helps us map the structure and scale of the galaxy. The Milky Way is not static. It's a place of constant change, where even the stars are restless, shifting, breathing in their own slow rhythms. Deep within the disk of the Milky Way, there are regions so thick with dust that they appear as dark rifts in the otherwise bright band of the galaxy. These are some of the most opaque clouds in the galaxy, blocking nearly all visible light from the stars behind them. One of the most famous is the Great Rift, a series of overlapping dust clouds that runs along the Milky Way's visual band in the night sky, particularly prominent when viewed from dark locations on Earth. To ancient cultures, these dark patches held significance. The Inca, for example, saw shapes in the dark clouds, animals and figures formed by the absence of light rather than its presence. Modern astronomers study these regions with infrared telescopes, peering through the dust to observe the stars forming within. What looks like emptiness to the naked eye is actually some of the most active, dynamic real estate in the galaxy. Regions where the future is being built, star by star, planet by planet, in darkness and silence. It's a reminder that sometimes the most important things are hidden, that absence can be as meaningful as presence, and that you don't need to see everything to know it's there. Our galaxy is surrounded by satellite galaxies, smaller galaxies that orbit the Milky Way, held captive by its gravity. The two most prominent are the large and small Magellanic Clouds, visible from the southern hemisphere as bright, fuzzy patches in the night sky. These dwarf irregular galaxies contain billions of stars and are currently being slowly torn apart by the Milky Way's tidal forces. Streams of gas and stars are being pulled from them, creating long bridges and trails that eventually will be incorporated into our galaxy. In a way, the Magellanic Clouds are being consumed, but slowly, over hundreds of millions of years. There are dozens of other satellite galaxies as well, most of them much smaller and fainter, tiny collections of stars orbiting far out in the galactic halo. Some are so faint they were only discovered recently, hidden in the sky like whispers. These satellites are remnants of a time when the Milky Way was actively assembling itself, growing by merging with smaller neighbors. The ones that remain today are survivors, but their fate is likely sealed. Eventually, they too will be absorbed, their stars added to the Milky Way's population, another chapter in the long story of galactic growth. Change is inevitable. Even galaxies cannot remain the same forever. The Milky Way has magnetic fields threading through it, weak by everyday standards, but significant on cosmic scales. These magnetic fields are generated by the motion of charged particles in the interstellar medium, and by the magnetic activity of stars, and they play a subtle but important role in the galaxy's ecology. They influence how gas collapses to form stars. They guide the motion of cosmic rays, high-energy particles that zip through the galaxy at nearly the speed of light. And they may even affect the shapes of supernova remnants and the structure of the interstellar medium. Mapping these magnetic fields is difficult. They're invisible, intangible, detectable only through their effects on light and matter. But astronomers are slowly piecing together a picture of the Milky Way's magnetic skeleton, the invisible framework that helps shape the visible structure we see. It's a bit like discovering that beneath the surface of something familiar, there's an entire hidden layer you never noticed before, a secret architecture that's been there all along, quietly doing its work. The universe is full of these hidden layers, and every time we discover one, the picture becomes richer, more complex, more wonderful. Cosmic rays are another invisible component of the Milky Way. High-energy particles, mostly protons, that travel through space at nearly the speed of light, constantly bombarding everything, including Earth. They originate from various sources within the galaxy: supernova remnants, pulsars, possibly even the supermassive black hole at the center. When cosmic rays strike Earth's atmosphere, they collide with air molecules, creating showers of secondary particles that rain down on the surface. Despite their name, cosmic rays aren't rays of light, they're particles, bits of matter accelerated to incredible energies by violent astrophysical processes. Most of them are harmless to us on the surface, absorbed by the atmosphere, but astronauts and airline passengers receive slightly higher doses. Cosmic rays are one of the galaxy's ways of reminding us that space isn't empty and benign, it's filled with energies and particles, a dynamic environment that life on Earth is shielded from by our planet's magnetic field and atmosphere. We live in a protective bubble, and it's easy to forget how hostile the space beyond that bubble can be. But we're safe here for now. You're safe. You can relax. Within the Milky Way, there are stars that predate the formation of the galactic disk. Stars so old they formed when the universe was still in its relative infancy. These are population II stars, found mostly in the halo and in globular clusters, and they have a very different chemical composition from younger stars like the Sun. They contain very few heavy elements, mostly just hydrogen and helium, because they formed before generations of supernovae had enriched the interstellar medium with carbon, oxygen, iron, and other elements. Studying these ancient stars gives astronomers a window into the early history of the galaxy and the universe itself, a glimpse of what conditions were like more than 10 billion years ago. These stars are witnesses to the birth of the Milky Way, silent observers who have watched the galaxy grow and change around them, and they'll continue watching long after our sun has faded. There's a dignity in that kind of longevity, a quiet endurance that feels almost noble. They've seen so much, and they're still here, still shining, still holding their place in the cosmic tapestry. The spiral arms of the Milky Way are not just pretty structures, they're engines of evolution. The increased density of gas and stars in the arms means more frequent supernova explosions, more intense radiation, more gravitational disturbances. As our solar system orbits the galaxy, it passes through spiral arms periodically, roughly every few 100 million years. Some scientists have speculated that these passages might be linked to periods of increased extinction events on Earth, as cosmic rays and nearby supernovae could affect the planet's climate or increase mutation rates in living organisms. The evidence is still debated, but it's a fascinating idea that the history of life on Earth might be partially written by our galaxy's structure, that the evolution of species, the rise and fall of ecosystems, could be influenced by our slow journey around the Milky Way. We tend to think of Earth's history as isolated, shaped only by events on and near the planet, but we're part of a galaxy, and the galaxy has always been part of our story, whether we realized it or not. Everything is connected. Even the deepest history of life on this small world is entwined with the grand motions of the stars. You're halfway through now, or maybe you've already drifted away into dreams, and that's wonderful. If you're still here, still listening, let your muscles soften just a little more. Unclench your jaw. Let your tongue rest gently in your mouth. Feel the weight of your body sinking into the bed, supported, held. The galaxy has been turning for billions of years, and it will keep turning. There's no rush, no urgency, just the slow, patient unfolding of time and space. Breathe, drift, let go. Among the most mysterious phenomena in the Milky Way are fast radio bursts, extremely brief, intense pulses of radio waves that last only milliseconds but release as much energy as the sun emits in days. For years, their origin was unknown, and most of the detected bursts came from distant galaxies. But recently, astronomers detected a fast radio burst from within our own galaxy, originating from a magnetar, a type of neutron star with an extraordinarily powerful magnetic field. This discovery provided the first concrete link between magnetars and fast radio bursts, solving part of the mystery. But questions remain. Why do some magnetars produce these bursts and others do? What triggers them? And are there other sources we haven't identified yet? The Milky Way is full of these puzzles, phenomena that challenge our understanding and invite us to keep looking, keep questioning, keep exploring. Science is not a collection of answers. It's a process of asking better questions, of refining our curiosity, of admitting what we don't know and feeling excited about the discovery waiting just beyond the edge of knowledge. And right now, you don't need to understand it all. Just know that the universe still holds secrets, and that's okay. Mystery is not a problem. It's an invitation. The center of the Milky Way is shrouded in dust, making it impossible to see invisible light. But in other wavelengths, infrared, X-ray, radio, the galactic center reveals itself as one of the most active and energetic regions in the entire galaxy. Around the central black hole, Sagittarius A star, there exists a dense cluster of stars, with some orbiting the black hole at tremendous speeds. Astronomers have tracked the orbits of these stars for decades, watching them whip around the black hole in elliptical paths, their motion providing direct evidence for the black hole's existence and allowing precise measurements of its mass. One star, designated S2, completes an orbit in just 16 years, reaching speeds up to 3% of the speed of light at its closest approach. Observing these stars is like watching a cosmic ballet, choreographed by gravity, performed on the most extreme stage in the galaxy. And at the center of it all, the black hole itself, invisible, silent, known only by the effect it has on everything around it. It's the ultimate hidden conductor, orchestrating the motion of stars without ever revealing itself. There's a strange beauty in that, a power that doesn't need to announce itself, that simply is. Scattered throughout the Milky Way are planetary nebulae, glowing shells of gas ejected by dying stars. Despite their name, they have nothing to do with planets. The name comes from early astronomers who, viewing them through small telescopes, thought they looked somewhat like planets, round, diffuse, disk-like. In reality, they're the outer layers of a star like the Sun, gently blown off into space as the star exhausts its nuclear fuel and swells into a red giant, then sheds its envelope. What remains is the hot core of the star, now called a white dwarf, which emits intense ultraviolet radiation that ionizes the surrounding gas and makes it glow in beautiful colors, reds, greens, blues, depending on the elements present. Planetary nebulae are among the most visually stunning objects in the galaxy, intricate and delicate, each one unique, like cosmic flowers blooming briefly before fading into the darkness. They're reminders that endings can be beautiful, that the final acts of a star's life can be as glorious as its youth. And they're also recycling centers. The gas they return to space is enriched with heavy elements forged in the star's core, material that will eventually be incorporated into new stars, new planets, new chances at complexity. Death is not an ending. It's a transformation. The Milky Way is filled with echoes, light echoes to be precise. When a star explodes as a supernova, it releases a burst of light so bright it can briefly outshine the entire galaxy. This light travels outward in all directions, and when it encounters clouds of interstellar dust, it reflects off the dust and scatters toward us, arriving years, decades, or even centuries after the initial explosion. By observing these light echoes, astronomers can study supernovae that occurred long ago, effectively traveling back in time to witness events that would otherwise be lost to history. One of the most famous examples is the light echo from a supernova that occurred in the year 1987, the closest observed supernova in modern times. Light echoes from that explosion are still being detected today, bouncing off dust clouds at various distances and angles, allowing scientists to reconstruct what the explosion looked like from different perspectives. It's a bit like hearing an echo in a canyon, except the canyon is made of interstellar dust, and the shout is the death cry of a star. The galaxy remembers. It holds onto these moments, reflects them, lets them ripple outward long after the original event has faded. In a way, nothing is ever truly gone. The past lingers, carried on waves of light and gravity, woven into the structure of space itself. One of the most counterintuitive facts about the Milky Way is that despite containing hundreds of billions of stars, the vast majority of the galaxy's volume is empty space. If you were to shrink the sun down to the size of a grain of sand, the nearest star would be about 4 miles away. Scale that up to the entire galaxy, and you realize that stars are scattered across unimaginable distances, tiny islands of light in an ocean of darkness. This emptiness is why galaxy collisions are not as catastrophic as they might seem. When galaxies merge, the stars almost never collide because there's so much space between them. But this emptiness is also what makes the night sky so dark, even though we're surrounded by stars. The distances are so vast that most of the light from most of the stars never reaches us, or reaches us so faint we can't perceive it. We live in a universe that is mostly empty, mostly dark, mostly silent. And yet, that emptiness is not nothing. It's threaded with gravity, magnetic fields, invisible dark matter, the hum of cosmic microwave background radiation. The emptiness is full, in its own way. And in the quiet spaces between things, there's room to breathe, to rest, to simply be. Our position in the Milky Way, far from the center, out in a quiet spiral arm, might seem unremarkable, but it's actually quite fortunate. The galactic habitable zone is a concept that suggests certain regions of the galaxy are more conducive to the development of life than others. Too close to the center, and the density of stars, the frequency of supernovae, the intensity of radiation makes stable planetary systems unlikely. Too far from the center, and there might not be enough heavy elements to form rocky planets in the first place, since elements like carbon, oxygen, and iron are produced in stars and spread through the galaxy over time. The sweet spot is somewhere in the middle, in the galactic suburbs, where stars are spaced comfortably apart. Supernovae are rare enough not to be an existential threat, and there's a good mix of elements for building planets and biochemistry. We live in that sweet spot, and it's part of the reason we're here at all. Sometimes the best place to be is not in the center of things, not where the action is most intense, but on the edges, where there's room to grow, room to breathe, room for life to unfold slowly and patiently over billions of years. There's wisdom in that, a reminder that you don't always need to be in the thick of things to matter, to have value, to be exactly where you're supposed to be. The Milky Way is not isolated in space. It's part of a larger cosmic structure, and it's being pulled by gravity in various directions. Besides the motion toward the great attractor, the Milky Way is also part of a larger flow of galaxies called the Laniakea supercluster, a collection of over 100,000 galaxies spanning 520 million light-years, all moving together, flowing like water toward a common center of mass. The name Laniakea comes from Hawaiian words meaning immeasurable heaven, and it's a fitting name for something so vast it defies easy comprehension. We're part of this immense structure, a single galaxy among multitudes, all connected by gravity, all participating in a cosmic dance that operates on scales we can barely visualize. It's humbling, but also comforting. You're part of something much larger than yourself, and that's true on every scale. You're part of a family, a community, a species, a planet, a solar system, a galaxy, a supercluster. All of it nested together, all of it connected. You belong here. You're exactly where you're meant to be. Stars in the Milky Way have different metallicities, that is, different amounts of elements heavier than hydrogen and helium. Astronomers call these heavy elements metals, even though they include things like oxygen and carbon that aren't metallic in the everyday sense. Stars that formed recently, like the Sun, have higher metallicity because they formed from gas that had been enriched by previous generations of stars. Ancient stars, on the other hand, have very low metallicity, sometimes thousands of times less than the Sun, because they formed from nearly pristine primordial gas. By measuring the metallicity of stars, astronomers can estimate their age and trace the chemical evolution of the galaxy over billions of years. It's like reading tree rings, except the rings are written in starlight and chemical abundances, and the tree is the entire galaxy. Each star carries within its spectrum a record of when and where it was born, a signature written in the elements it contains. The Milky Way is a history book, and every star is a page, waiting to be read. The Milky Way produces about one new star per year on average. This rate has varied over the galaxy's history. There were periods of intense star formation early on, and the rate has slowed over time as the gas supply diminishes. But still, every year, somewhere in the galaxy, a new star ignites, a new light appears in the darkness. Think about that. Right now, as you lie here listening, a cloud of gas and dust somewhere in the Milky Way might be collapsing, heating, compressing, approaching the threshold where nuclear fusion will begin, where a new star will be born. It's happening constantly, quietly, without fanfare. And every one of those stars is a potential sun for a family of planets, a potential source of warmth and light for worlds we will never see. The Milky Way is still creating, still birthing new stars, still growing and renewing itself. And in that ongoing process of creation, there's hope that the story isn't over, that new chapters are being written, that the future is not fixed but open, full of possibilities we can't yet imagine. And you, listening right now, are part of that story. Your life, brief as it is on cosmic scales, is woven into the fabric of this ongoing creation. You matter. Your existence is part of the universe experiencing itself. Somewhere out there in the Milky Way, there are stars that have already died, but we don't know it yet. Because light takes time to travel, and because the galaxy is so vast, there are stars whose light is still traveling toward us, but which have already exhausted their fuel, collapsed, or exploded. When we look up at the night sky, we're not seeing the galaxy as it is now, we're seeing it as it was, a collection of different moments in time, layered together. That star might have died 1,000 years ago, but its light is still on the way. It's still crossing the emptiness of space, still approaching, and when it finally arrives, if it arrives, someone might look up and see it wink out or flare into a supernova, and they'll be witnessing something that happened long ago, an event already finished, a story already told, but only now reaching its audience. Time and space are tangled together in the universe, and we are always looking backward into the past, trying to piece together the present from light that has traveled through the ages. It's a little like memory, isn't it? The way we carry the past with us, the way it shapes how we see the present, the way we can never quite live in the now because the now is always slipping into the past even as we reach for it. But that's okay. The universe works the same way. You're not alone in that. The Milky Way has weather patterns on a galactic scale, fountains of gas rising from the disk into the halo, then cooling and falling back down like rain. These are driven by the energy released by supernova explosions and intense star formation, which heats the gas and causes it to expand upward out of the disk, where it cools and eventually falls back. This galactic fountain helps mix material throughout the galaxy, redistributing elements and cycling matter between the disk and the halo. It's a slow process, taking millions of years, but it's part of what keeps the galaxy dynamic and prevents all the gas from settling into a static configuration. The Milky Way breathes, in a way, inhaling gas from the intergalactic medium, exhaling it back out, recycling and renewing itself over and over. It's a reminder that even on the largest scales, systems need circulation, need movement, need exchange with their surroundings to stay alive and vibrant. Nothing is truly isolated. Everything is part of a larger system, giving and receiving, participating in flows and cycles that sustain the whole. There are clouds in the Milky Way so cold that they're only a few degrees above absolute zero, the coldest possible temperature in the universe. In these clouds, molecules move sluggishly, reactions proceed at glacial paces, and the environment is about as close to stillness as the universe allows. And yet, even here in these frozen, dark regions, stars are born. Gravity acts patiently, slowly pulling material together, and eventually the compression generates heat, the cloud fragments, cores collapse, and new stars ignite, bringing warmth and light to regions that have been cold for millions of years. It's a paradox. The coldest places in the galaxy are also birthplaces of fire. From stillness comes motion. From darkness comes light. From cold comes warmth. The universe is full of these transformations, these reversals, these moments when the conditions seem least favorable for creation, and yet creation happens anyway. It's a reminder that beginnings can come from anywhere, even from the most unlikely places, and that potential exists even in environments that seem barren or lifeless. There's always a chance for something new. Always. The Milky Way is old, but it's not the oldest galaxy in the universe. Some galaxies formed when the universe was only a few 100 million years old, ancient structures whose light has been traveling toward us for over 13 billion years. By the time that light reaches our telescopes, we're seeing those galaxies as they were in the earliest epochs of cosmic history, small and irregular, full of young stars and intense star formation. Our galaxy, by comparison, formed later, assembling gradually over the first few billion years of the universe's history. This means the Milky Way is a product of a more mature cosmos, a galaxy that had the benefit of time, that could draw on material already enriched with heavy elements from earlier generations of stars. In a way, we're standing on the shoulders of giants, cosmic giants, galaxies and stars that came before, that laid the groundwork that made it possible for galaxies like ours, and systems like our solar system and worlds like Earth to exist. Nothing we have, nothing we are exists in isolation. It's all built on what came before, layer upon layer, generation upon generation, stretching back to the very beginning. And that lineage is worth honoring, worth remembering, even as you drift toward sleep. The Milky Way contains at least a few 100 billion planets, and among them are likely many that resemble Earth, rocky worlds orbiting in the habitable zones of stable stars, with atmospheres and liquid water and perhaps even life. We haven't found them all yet. We've barely begun to search. But statistical models based on the thousands of exoplanets we have discovered suggest that Earth-like worlds are common in the galaxy. There might be tens of billions of them. Imagine that. Tens of billions of places where the conditions for life might exist. Some might be too hot or too cold, too dry or too hostile. But some might be just right, and on those worlds, life might have arisen, might be evolving, might be looking up at their own night sky and wondering if they're alone. We don't know yet. But the possibility is there, vast and hopeful, a reminder that the universe is not a sterile void but a place brimming with potential, full of chances for complexity and consciousness to arise. And if life is common, then we're part of a galactic family we haven't met yet, brothers and sisters scattered among the stars, all of us children of the same cosmic processes, all of us made from the same stardust, wondering the same questions. Among the most energetic events in the Milky Way are gamma-ray bursts, brief, intense flashes of gamma rays that can release more energy in a few seconds than the sun will emit in its entire lifetime. Most gamma-ray bursts come from distant galaxies, associated with the collapse of massive stars or the merger of neutron stars, but occasionally they occur in our own galaxy. If a gamma-ray burst occurred too close to Earth, it could be catastrophic, stripping away the ozone layer and exposing the surface to harmful radiation. Fortunately, such events are extremely rare, and the geometry has to be just right. The burst is emitted in narrow jets, so you have to be in the line of fire. The chances are very low, but the fact that such powerful events exist at all is a reminder of the energies at play in the universe, forces so immense they humble our imagination. The Milky Way is not a tame place. It's a place of both gentle beauty and violent extremes, and we're fortunate to live in a time and place where those extremes are distant enough not to harm us, but close enough to inspire awe. The supermassive black hole at the center of the Milky Way, Sagittarius A star, is surprisingly quiet right now. It's not actively feeding, not pulling in large amounts of matter, and as a result, it doesn't emit much radiation. But that hasn't always been the case. Evidence suggests that in the past, perhaps a few million years ago, the black hole was much more active, accreting matter and emitting powerful jets and radiation. The Fermi bubbles, those enormous lobes of high-energy gas extending above and below the galactic plane, are thought to be remnants of that period of activity. The black hole burped, essentially, expelling vast amounts of energy into the surrounding space, and those bubbles are the afterglow still visible millions of years later. It's a reminder that even the quietest things have a past, a history of activity and change, and that what we see now is just one moment in a much longer story. Sagittarius A star is resting now, but who knows when it might wake again, when it might begin feeding once more, flaring back to life. For now, though, it sits quietly at the heart of the galaxy, patient and still, anchoring everything around it. The Milky Way is losing gas. Not quickly but steadily, gas is being stripped from the galaxy by interactions with the hot, diffuse intergalactic medium and by outflows driven by supernovae and stellar winds. At the same time, the galaxy is also accreting new gas from the intergalactic medium and from infalling satellite galaxies, replenishing its supply. This balance between loss and gain determines the galaxy's star formation rate. If the inflow exceeds the outflow, star formation can continue. If the outflow dominates, the galaxy will gradually run out of raw material and star formation will slow, eventually ceasing altogether. Billions of years from now, after the merger with Andromeda, the resulting galaxy, Milkomeda, will likely exhaust much of its gas supply and become a quiescent elliptical galaxy, full of old stars, with very little new star formation. It will be a quieter place, more settled, less dynamic. But that's still billions of years away. For now, the Milky Way is alive, active, creating, and you're here to witness it, even if only in this small, quiet way, lying in the dark, listening to a voice telling you about stars. Among the stars in the Milky Way, there are some that are, in a sense, time travelers. Stars captured from other galaxies during past mergers now orbit within the Milky Way, but they carry with them the chemical signatures of their birth galaxies. By studying these stars, astronomers can reconstruct the history of the Milky Way's growth, identifying which stars came from which ancient mergers, piecing together a family tree of galactic ancestry. One such merger, called the Gaia-Enceladus sausage merger, occurred about 10 billion years ago, when a large dwarf galaxy collided with the young Milky Way and was torn apart. Many of the stars in the halo today are remnants of that event, immigrants from a galaxy that no longer exists. They're orphans in a way, but they've found a new home here, and their presence enriches the Milky Way, adding diversity and history. In a way, we're all descendants of mergers and mixings, blending of different lineages, and that's true not just for galaxies, but for people, for cultures, for ideas. Nothing is pure. Everything is a mix, a fusion, a coming together of different threads into something new. And that's not a weakness. It's a strength. Let your thoughts become softer now. There's no need to hold onto the details, no need to remember the names or numbers. Let them slip away like water through your fingers. The Milky Way doesn't need you to understand it. It's content just to exist, spinning quietly in the dark, and you can be content too, just existing, just breathing, just being. Feel the rise and fall of your chest. Notice how effortless it is. Your body knows how to rest. Trust it. Let it carry you into sleep. Our view of the Milky Way from Earth is unique. We're embedded within it, seeing it edge on as a band of light across the sky. But if you could leave the galaxy and view it from outside, it would appear as a majestic spiral, arms gracefully curving outward from the central bar, glowing with the light of hundreds of billions of stars. From a distance, the Milky Way would look similar to other spiral galaxies we observe, like Andromeda or the Triangulum Galaxy. It would be beautiful, elegant, a cosmic work of art suspended in the void. But we don't get that perspective. We're inside, looking out, trying to map the structure from within, like being a single cell trying to understand the shape of the body it's part of. There's something humbling about that limitation, but also something intimate. We know our galaxy from the inside. We live within it, are part of it, carry it with us in every atom of our bodies. We don't need to see it from outside to know it. We feel it. We are it. The center of the Milky Way is believed to contain a dense nuclear star cluster, a region where stars are packed so tightly that stellar collisions and interactions are far more common than anywhere else in the galaxy. This cluster surrounds the supermassive black hole and contains millions of stars in a volume only a few light years across. Some of these stars are massive and short-lived, burning bright and fast before ending in supernovae. Others are older, quieter, red giants that have wandered into this chaotic environment. The dynamics of the nuclear star cluster are complex and still not fully understood. Gravity, radiation pressure, tidal forces, and the influence of the black hole all play roles in shaping how stars move and interact. It's a cosmic laboratory, a place where extreme conditions reveal aspects of stellar physics we can't observe anywhere else. And yet, despite the chaos, the system maintains a kind of balance, a dynamic equilibrium that has persisted for millions of years. Even in chaos, there can be patterns. Even in intensity, there can be stability. The Milky Way's disk is not perfectly flat. It's warped, bent, twisted at the edges like the brim of a hat that's been sat on. This warping is thought to be caused by gravitational interactions with satellite galaxies, particularly the Magellanic Clouds, whose gravity tugs on the outer regions of the Milky Way's disk, distorting its shape. The warp is subtle, only a few thousand light-years of deflection over the vast span of the galaxy, but it's there, a reminder that the Milky Way is not a static, rigid structure but a flexible, dynamic system constantly being reshaped by the forces acting on it. Everything responds to everything else. Nothing exists in isolation. The Magellanic Clouds pull on us, we pull on them, and the dance continues, reshaping both partners over time. It's a metaphor worth holding on to, how we shape and are shaped by the people and forces around us, how nothing we do occurs in a vacuum, how every action has ripples, seen and unseen, spreading outward. One of the most mysterious components of the Milky Way's halo is a population of ultra-faint dwarf galaxies, tiny collections of stars so faint they're almost invisible. These galaxies contain very few stars, sometimes only a few thousand, and they're dominated by dark matter, with normal matter making up only a tiny fraction of their total mass. They're fossils, in a way, relics from the early universe, small systems that formed early and then mostly stopped evolving, preserved in the gravitational embrace of the Milky Way. Studying them gives astronomers clues about how galaxies form, about the role of dark matter in structure formation, and about the conditions in the early universe. They're like messengers from a distant past, carrying information across billions of years, and only recently have our telescopes become sensitive enough to detect them. The Milky Way is full of these hidden treasures, faint and easy to overlook, but rich with meaning for those who take the time to look closely. Sometimes the quietest voices have the most important stories to tell. Within the disk of the Milky Way, there are regions called associations, loose groupings of young, massive stars of spectral types O and B, which are the hottest, brightest, and most short-lived stars in the galaxy. These associations form when giant molecular clouds collapse and fragment into mini stars, and the most massive stars live fast and die young, exploding as supernovae within just a few million years. The combined radiation and stellar winds from these stars blow away the remaining gas in the region, dispersing the cloud and preventing further star formation, effectively destroying the environment that created them. It's a self-limiting process. The brightest stars burn so intensely they consume and disperse the very material they need to keep forming new stars. Associations are ephemeral, lasting only a few tens of millions of years before the stars drift apart and the association dissolves. But in that brief window, they're some of the most energetic and luminous regions in the galaxy, lighting up entire spiral arms with their fierce blue-white glow. They're a reminder that intensity and longevity are often inversely related, that burning bright comes at a cost, and that sometimes the most beautiful things are also the most fleeting. The concept of stellar populations extends beyond just age and metallicity. Population-I stars like the Sun are young, metal-rich, and found in the disk. Population-II stars are old, metal-poor, and found in the halo and globular clusters. But there's also a theoretical population-III, stars that formed in the very first generation after the Big Bang, made entirely of hydrogen and helium with no heavy elements at all. These stars would have been massive, hundreds of times the mass of the Sun, burning hot and fast, living only a few million years before exploding and seeding the universe with the first heavy elements. No population-III stars have ever been observed. They all died long ago, but their existence is inferred from the chemical abundances we see in the oldest population-II stars. They were the pioneers, the first lights in a dark universe, and their legacy is written in every star, every planet, every atom of your body. You are connected to that first generation, linked by an unbroken chain of creation and destruction, recycling and renewal, stretching back to the very beginning. You carry the memory of the first stars within you, even if you don't know it. And that's a kind of immortality. The Milky Way's rotation is not uniform. It exhibits what's called a flat rotation curve, meaning that stars far from the galactic center move at roughly the same speed as those closer in, rather than slowing down as you'd expect from Kepler's laws of planetary motion. This flat rotation curve is one of the strongest pieces of evidence for dark matter. If only the visible matter were present, the outer stars should move more slowly, their orbits governed by the gravitational pull of the stars and gas we can see. But they don't. They move faster, as if there's more mass out there than we can account for. And there is dark matter, distributed in a vast halo around the galaxy, providing the extra gravitational glue that holds everything together and explains the rotation curve. This discovery was made decades ago, and it revolutionized our understanding of galaxies and the universe. It revealed that what we see is not all there is, that the universe has hidden depths, invisible layers that shape the visible world. It's humbling but also exhilarating, a reminder that there's always more to discover, always another layer beneath the surface, always another mystery waiting to be unraveled. Stars in the Milky Way move in complex orbits, not simple circles. Each star has its own trajectory, influenced by the combined gravitational pull of all the other stars, the dark matter halo, and the overall structure of the galaxy. Some stars follow nearly circular orbits, staying close to the galactic plane. Others have highly elliptical orbits, plunging in toward the center, and then swinging out to the halo and back again. Still others bob up and down through the disk as they orbit, like carousel horses. The result is a complex web of intersecting paths, a cosmic traffic pattern that somehow never results in collisions because space is so vast and stars so small. Each star's orbit is unique, shaped by its history, by the gravitational encounters it's experienced, by the forces acting on it over billions of years. In a way, it's like people, each of us moving through life on our own trajectory, influenced by countless factors, crossing paths with others, sometimes briefly, sometimes for longer, but ultimately following a path that's uniquely ours. And all those individual paths woven together create the larger structure, the community, the galaxy. We're all part of something bigger, even as we remain individuals. The Milky Way has a bar, a rectangular structure of stars extending from the central bulge, oriented roughly perpendicular to our line of sight from Earth. This bar is a common feature in spiral galaxies, and it plays an important role in the galaxy's dynamics. The bar acts like a gravitational highway funneling gas from the outer disk toward the center, where it can fuel star formation or feed the central black hole. The bar rotates as a single, solid structure, and its gravitational influence shapes the orbits of stars and the distribution of gas throughout the inner galaxy. Bars are thought to form through instabilities in the disk, growing over time as the galaxy evolves. Our bar is about 27,000 light-years long and rotates with a period of a few 100 million years. From our vantage point, it's not immediately obvious. We're embedded in the disk, looking through it, and the bar is seen at an angle, but observations in infrared light reveal its presence clearly. It's one more piece of the Milky Way structure, one more layer of complexity in the grand architecture of our home galaxy. Throughout the Milky Way, there are stellar streams, long, thin trails of stars stretching across the sky, remnants of disrupted globular clusters and dwarf galaxies. These streams form when a smaller system passes too close to the Milky Way and is pulled apart by tidal forces, stretched into a long ribbon that traces the orbit of the original object. Some of these streams are ancient, the remains of mergers that occurred billions of years ago. Others are more recent, still relatively coherent. By mapping these streams and studying the motion of the stars within them, astronomers can reconstruct the history of the Milky Way's growth and probe the distribution of dark matter in the galactic halo. The streams are like breadcrumbs left behind by the galaxy's past, trails that lead back to earlier eras, to events long concluded but still visible in their aftermath. The universe remembers. It records its history in structures like these, and if we're patient, if we look carefully, we can read that history and understand where we came from, how we got here, and what forces shaped the galaxy we call home. The Milky Way emits light across the entire electromagnetic spectrum, from low-energy radio waves to high-energy gamma rays. Each wavelength reveals different aspects of the galaxy's structure and activity. Radio observations map cold hydrogen gas and trace the spiral arms. Infrared sees through dust, revealing star-forming regions and the crowded galactic center. Visible light shows us the stars themselves, the galaxy as our eyes perceive it. Ultraviolet highlights hot, young stars and the glowing gas around them. X-rays reveal high-energy phenomena, supernova remnants, accreting black holes, hot gas in the galactic halo. Gamma rays mark the most violent events, pulsars, cosmic ray interactions, and possibly the annihilation of dark matter. To understand the Milky Way fully, we need to observe it in all these wavelengths, assembling a composite picture that no single view could provide. It's a bit like understanding a person. You can't know someone by looking at them only from one angle, under one kind of light. You need to see them in different contexts, different moods, different situations. The Milky Way is the same. It's multifaceted, complex, and every wavelength adds another dimension to our understanding. Astronomers have recently discovered that the Milky Way has a heartbeat, a rhythmic oscillation in the density and motion of stars in certain regions of the disk, possibly caused by the gravitational influence of a dwarf galaxy that passed through the disk millions of years ago. This discovery was made using data from the Gaia spacecraft, which has measured the positions and motions of over 1 billion stars with unprecedented precision. The oscillation is subtle, but it's there, a ripple in the disk that speaks to past interactions, past disturbances that set the stars ringing like a bell. The Milky Way is not static. It responds to the events that shape it, and those responses can persist for millions of years, echoes of long-ago encounters still reverberating through the structure. It's a reminder that the past is never truly past. It lives on in the present, shaping it, influencing it, leaving traces that can be detected if you know where to look. And the same is true for us for our lives. The things that happen to us, the people we meet, the experiences we have, they all leave ripples, shaping who we are, influencing the paths we take, long after the original event has passed. One of the most intriguing questions about the Milky Way is whether it has undergone a major merger in its past. Evidence suggests that it has, several times in fact. Smaller galaxies have been absorbed over billions of years, their stars and gas added to the Milky Way's mass. But there's also evidence for at least one larger merger, when a sizable dwarf galaxy collided with the Milky Way and was torn apart, contributing a significant fraction of the halo stars we see today. This event, sometimes called the Gaia-Enceladus merger, happened about 8 to 10 billion years ago, and it likely had a profound impact on the galaxy's structure and evolution. Mergers are transformative. They're violent in the sense that they involve immense gravitational forces, but they're also creative, mixing materials, triggering star formation, reshaping structures. The Milky Way we see today is in part the product of those ancient collisions, those long-ago minglings. And in the future, the merger with Andromeda will transform it again. Change is the only constant, and the Milky Way embodies that truth. The spiral arms of the Milky Way are not static features but waves, density waves that propagate through the disk, compressing gas and triggering star formation as they pass. This means the stars we see in the spiral arms today are not the same stars that were in those arms 100 million years ago. Stars drift into the arms, linger for a while as they move through the denser region, and then drift out the other side, continuing their orbits around the galaxy. The arms themselves persist, but the material within them is constantly changing. It's a bit like a traffic jam on a highway. The jam stays in roughly the same place, but the cars within it are always changing as some exit and others enter. This dynamic picture of spiral arms is one of the triumphs of modern astrophysics, explaining how these structures can persist for billions of years without winding up into a tight spiral or dissolving altogether. The galaxy is a living, breathing entity, and its structures are patterns in motion, not fixed objects. Everything flows, everything changes, and yet the patterns endure. There are regions in the Milky Way where star formation has recently stopped, areas that were once vibrant stellar nurseries but are now quiet, their gas depleted or dispersed. These post-starburst regions contain populations of young stars no longer being replenished, slowly aging and evolving as the stellar population reddens and fades. Studying these regions helps astronomers understand what triggers and what quenches star formation, how galaxies transition from active to passive states, and what the future of the Milky Way might look like. Star formation can't continue forever. Eventually, the gas will run out, either consumed in making stars or blown away by stellar winds and supernovae. When that happens, the galaxy will grow quieter, calmer, filled with old stars slowly burning down, a sunset era for the Milky Way. But that's still billions of years away. For now, the galaxy is still in its prime, still creating, still vibrant. And so are you. You have time. There's no rush. Among the stars in the Milky Way, there are some that are, quite literally, made of the remnants of previous stars, white dwarfs, the dense, cooling embers left behind when stars like the Sun exhaust their fuel and shed their outer layers. A white dwarf is about the size of Earth but contains roughly the mass of the Sun, packed so tightly that a teaspoon of its material would weigh several tons. These objects no longer undergo fusion. They're simply radiating away their residual heat, slowly cooling over billions of years, eventually fading to black dwarfs, theoretical objects so cool they no longer emit visible light. No black dwarfs exist yet, the universe isn't old enough, but given enough time, every white dwarf will become one, the final resting state of stars like our sun. There's something peaceful about that image, a slow fade into darkness, a gentle ending, not violent, not dramatic, just a quiet cessation, a light going out softly. And in that ending there's a kind of grace. The Milky Way's disk contains not just stars and gas, but also a significant amount of dust, tiny grains of solid material, mostly carbon and silicates, that absorb and scatter light. This dust is produced by stars, blown off in stellar winds or ejected in supernova explosions, and it plays a crucial role in the life cycle of the galaxy. Dust grains provide surfaces where molecules can form, enabling complex chemistry that wouldn't otherwise occur in the cold, diffuse gas of space. Dust also absorbs ultraviolet and visible light, emitting it as infrared radiation, which helps cool dense clouds and allows them to collapse into stars. Without dust, the galaxy would look very different, brighter in some ways but less capable of forming new stars, less chemically rich, less complex. Dust is often seen as something dirty, something to be cleaned away, but in the galaxy, dust is essential. It's the foundation of complexity, the medium through which creation occurs. Maybe that's a lesson worth taking to heart, that what seems like mess or clutter can actually be the raw material for something new, something beautiful. One of the most enduring mysteries of the Milky Way is the exact nature of the galactic center. Even with infrared and radio telescopes that can peer through the dust, the environment there is so crowded and chaotic that disentangling what's happening is difficult. There's the supermassive black hole, yes, but also a dense cluster of stars, clouds of gas, magnetic fields, possibly multiple stellar mass black holes orbiting nearby. The dynamics are complex, and the region is constantly changing. Occasionally, a star or gas cloud wanders too close to Sagittarius A star and is torn apart, briefly flaring in X-rays or other radiation as the material spirals inward. These tidal disruption events are rare, but they provide some of the best opportunities to study how black holes accrete matter. The galactic center is a frontier, a place where our understanding is still incomplete, where new observations continue to surprise us. And that's okay. Not everything needs to be understood right now. Mystery is part of the beauty. It's what keeps us curious, keeps us looking, keeps us wondering. How are you feeling? Heavy and relaxed, I hope. Let your eyelids grow heavier if they haven't already. Let your mind wander wherever it wants to go, back to the stars, or forward into dreams, or nowhere at all, just floating in the quiet dark. There's no destination, no place you need to arrive. Just this moment, this breath, this gentle drift. The Milky Way has been here for billions of years, and it will be here tomorrow. You don't need to see it all tonight. You just need to rest. The Milky Way is home to phenomena called masers, cosmic microwave amplification by stimulated emission of radiation, essentially naturally occurring lasers in space. These masers occur in regions where specific molecules, like water or methanol, are excited by nearby stars or other energy sources, causing them to emit coherent microwave radiation. Masers are incredibly bright at specific frequencies and can be used to probe the conditions in star-forming regions, around evolved stars, and even in the accretion disks around black holes. They're tools, in a way, beacons that reveal otherwise hidden processes. The existence of masers is one of those delightful surprises the universe offers, nature doing something that seems almost technological, creating structured, coherent emission without any intention, without any design, just as a consequence of physics and chance. It's a reminder that the universe is endlessly inventive, full of phenomena we wouldn't predict, but which make perfect sense once we understand them. Throughout the Milky Way, there are binary systems where one star is a white dwarf and the other is a normal star, and material from the normal star is being pulled onto the white dwarf by gravity. This material accumulates on the surface of the white dwarf, and when enough builds up, the pressure and temperature trigger a thermonuclear explosion, a nova. Novas are not as powerful as supernovae, but they're still dramatic events, suddenly brightening the system by a factor of thousands or millions, making it visible even at great distances. The white dwarf survives the explosion, and the process can repeat, creating recurrent novas that flare up every few years or decades. These systems are laboratories for studying thermonuclear physics, accretion processes, and the evolution of binary stars. And they're also beautiful in their way, brief, brilliant flares of light in the darkness, reminders that even old, dying stars can still surprise us, can still shine brightly for a little while longer before fading again. The Milky Way's halo extends far beyond the visible disk, perhaps as much as 1,000,000 light-years from the galactic center, though it becomes increasingly diffuse at greater distances. This extended halo is dominated by dark matter, with only a sparse population of stars and globular clusters marking its presence. The boundary between the Milky Way and intergalactic space is not sharp. There's no clear edge where the galaxy ends and empty space begins. Instead, it's a gradual fading, a slow thinning of matter until eventually you reach regions where the density is so low that it's more intergalactic than galactic. This ambiguity is true of many things in the universe. Boundaries are often fuzzy, gradients rather than lines, transitions rather than walls. And that's okay. Not everything needs to be sharply defined. Sometimes the edges are the most interesting places, the places where one thing becomes another, where definitions blur and new possibilities emerge. Among the stars in the Milky Way, there are some that formed not in the galaxy itself, but in the intergalactic medium, rare events but possible, where gas in the space between galaxies becomes dense enough to collapse and form stars. These intergalactic stars are hard to detect because they're so isolated, but they're out there, drifting through the void, not part of any galaxy, solitary lights in the darkness. There's something both lonely and peaceful about that image, a star with no neighbors, no galactic home, just existing by itself in the vast emptiness. And yet it shines, it burns, it lives. Even alone, even isolated, it continues. Maybe there's a lesson there, that you can find light even in isolation, that being apart from the crowd doesn't mean you're extinguished, that even in the loneliest places, there can be warmth and meaning. The Milky Way has streams of high-velocity clouds, clouds of hydrogen gas moving through the halo at speeds much faster than typical galactic rotation would suggest. The origins of these clouds are debated. Some may be gas left over from the galaxy's formation, now falling back inward. Others may be material stripped from satellite galaxies, or gas expelled from the disk by supernova-driven winds that's now raining back down. These clouds are important because they represent a source of fresh gas that can fuel future star formation, replenishing the disk's supply of raw material. The galaxy isn't a closed system. It's constantly exchanging material with its surroundings, breathing in and out, cycling matter between the disk, the halo, and the intergalactic medium. Nothing is static. Everything flows. And in that flow, there's renewal, the possibility of continuation, the promise that the story isn't over yet. The Milky Way contains some of the oldest known objects in the universe, globular clusters with ages approaching 13 billion years, formed when the universe itself was less than 1 billion years old. These clusters are time capsules, preserving a snapshot of the early cosmos, and studying them helps astronomers calibrate the age of the universe and understand the conditions under which the first galaxies formed. The stars in these clusters are ancient, cool, and red, their light a faint ember glow. They've witnessed nearly the entire history of the universe, from shortly after the Big Bang to the present day. If stars had memories, these would be the elders, the storytellers, carrying within them the knowledge of ages upon ages. We can't speak to them, of course, but we can study their light, decode the messages written in their spectra, and in doing so touch the deep past, connect with a time before the sun, before Earth, before anything we recognize as home existed. It's humbling. It's also awe-inspiring. We are part of a story that stretches back to the beginning, and every time we look at one of these ancient stars, we're looking at a chapter from the first volume of that story. The Milky Way's future is intertwined with that of the Andromeda Galaxy. In about 4.5 billion years, the two galaxies will collide, though collide might be too violent a word. They will pass through each other, their stars rarely if ever touching due to the vast distances involved, but their gravitational interaction will distort and reshape both galaxies. Over the course of several billion years, they will merge, forming a single, larger galaxy, likely an elliptical galaxy, since the collision will disrupt the delicate spiral structures both galaxies currently possess. By the time this merger is complete, the Sun will likely have already entered its red giant phase, swelling and engulfing the inner planets. Life on Earth, if it hasn't already been extinguished by the Sun's evolution, will certainly be impossible by then. But the merger itself won't directly affect our solar system in any catastrophic way. The odds of our Sun colliding with another star are vanishingly small. We'll simply be part of a larger, differently shaped galaxy in a different location under a different night sky. Change is inevitable, but it's slow, patient, and often, when viewed from the right perspective, beautiful. The stars we see at night are not evenly distributed across the Milky Way. Most of them are within a few thousand light-years of Earth, a tiny fraction of the galaxy's full extent. The faintest stars visible to the naked eye are about 1,000 light-years away, and beyond that, individual stars are too dim to see without a telescope. This means our personal, unaided view of the galaxy is incredibly limited. We're seeing only our immediate neighborhood, a small bubble of space around the sun. Yet even this limited view contains hundreds of stars, each one a sun, possibly with its own planets, its own story. It's enough to fill the night sky with wonder, and it reminds us that even partial views, even limited perspectives, can be rich and meaningful. You don't need to see everything to appreciate the beauty around you. You don't need to understand the whole to find meaning in the part you can touch. The Milky Way is not the largest galaxy in the universe, nor the most massive. There are giant elliptical galaxies in the centers of galaxy clusters that contain trillions of stars, dwarfing our few hundred billion. But the Milky Way is large enough, complex enough, beautiful enough. It's home. And that's what matters. Size isn't everything. The Milky Way has given rise to at least one planet, Earth, where life has flourished, where consciousness has emerged, where beings have learned to look up at the stars and ask questions about their place in the cosmos. That's more impressive than sheer mass or size. The Milky Way is special not because it's the biggest or the brightest, but because it's ours, because we're part of it, because it's the stage on which our story unfolds. And every galaxy, no matter how small or large, is special to the beings within it, if any exist. Home is not defined by size. It's defined by connection, by belonging, by the meaning we find within it. The Milky Way's name is ancient, rooted in mythology and the very human need to explain the natural world. Many cultures have their own stories about the river of light across the sky. In some traditions, it's a path souls take to the afterlife. In others, it's a bridge between worlds. Some saw it as spilled milk from the breast of a goddess. Others saw it as the backbone of the sky or the seam where the heavens were stitched together. These stories reflect our deep need to find meaning in what we see, to weave narratives that connect us to the cosmos. Science has given us a different story, a tale of gravity, gas, stars, and time, but it's no less wondrous for being grounded in physics rather than myth. In fact, the scientific story deepens the wonder, revealing layers of complexity and beauty that the mythmakers could never have imagined. We're fortunate to live in an age where we can appreciate both, the poetry of myth and the precision of science, each enriching the other, each helping us understand our place in the universe. The Milky Way contains billions of solar systems, and among them, countless worlds unlike anything in our own system. There are hot Jupiters, giant planets orbiting closer to their stars than Mercury is to the Sun, their atmospheres blasted by radiation, their surfaces molten. There are rogue planets, wandering through interstellar space without a star, cold and dark, yet still existing, still following their own paths. There are super-Earths, rocky worlds larger than ours, with stronger gravity and thicker atmospheres. There are ocean worlds, ice worlds, lava worlds, planets orbiting binary stars, planets in chaotic orbits, planets so unlike Earth that we struggle to imagine what standing on their surfaces would feel like. The diversity is staggering, humbling, and exciting. It means the universe is not a monotonous place. It's a gallery of possibilities, each world a unique experiment in physics and chemistry, each one a potential home for something we haven't yet imagined. And somewhere among all those worlds, maybe, just maybe, someone else is lying down, looking up at their own night sky, listening to a voice tell them about the galaxy they live in, and feeling the same sense of wonder and peace that you're feeling now. Our Sun, in its journey around the Milky Way, has completed roughly 20 to 25 orbits since it formed about 4.6 billion years ago. That means the Sun is an experienced traveler, having seen the galaxy from many angles, having passed through spiral arms multiple times, having witnessed the slow changes in galactic structure over billions of years. And yet, from our perspective on Earth, none of that motion is apparent. We don't feel the Sun's movement through the galaxy. We don't see the stars shifting around us in response to our orbit. It all happens too slowly, on scales too vast for our senses to register. But it's happening. We're moving, always moving through space and time, part of currents and flows that dwarf anything we experience in our daily lives. And that's okay. You don't need to feel it to be part of it. You're carried along gently, safely, part of the galaxy's grand procession, and you can rest in that knowledge. You're exactly where you need to be, moving exactly as you should, part of something vast and ancient and ongoing. The Milky Way is thought to have formed through a combination of processes: gas collapsing under gravity, smaller galaxies merging together, dark matter halos attracting ordinary matter. The details are still being worked out, but the broad picture is one of hierarchical assembly, small structures forming first, and then gradually building into larger ones over billions of years. This bottom-up growth is a fundamental principle of cosmology, explaining not just galaxies but the entire large-scale structure of the universe. We're the product of that process, matter that started as tiny fluctuations in the density of the early universe, amplified by gravity over eons, eventually coalescing into galaxies, stars, planets, and us. There's a continuity there, a lineage that connects the first moments after the Big Bang to this moment right now, as you lie here listening. You are a direct descendant of the cosmos, shaped by the same forces that shaped galaxies, and that's a remarkable thing to be. Among the stars of the Milky Way, there are some that have planets with moons, and some of those moons might be more interesting, from a habitability standpoint, than the planets themselves. In our own solar system, moons like Europa, Enceladus, and Titan have captured the imagination of scientists searching for life, because they have subsurface oceans, complex chemistry, and energy sources that could support biology. It's possible, likely, even, that similar moons exist around gas giants in other star systems throughout the galaxy, hidden ocean worlds where life could arise far from the light of their parent star, sustained by tidal heating or chemical energy instead of photosynthesis. The Milky Way might be teeming with life not on planets, but on moons, places we're only just beginning to consider as potential habitats. It's a reminder that life, if it exists elsewhere, might not look like what we expect, might not be where we expect, and that the universe is full of surprises, full of possibilities we haven't yet imagined. The light from the Milky Way is so faint in many places on Earth now that most people never see it. Light pollution from cities and towns washes out the night sky, rendering the Milky Way invisible to billions of people. This is a loss, a disconnection from something ancient and meaningful. For thousands of generations, humans looked up and saw the river of light, told stories about it, used it to navigate, felt awe and wonder in its presence. Now for many, the night sky is empty except for a few bright stars and planets. But the Milky Way is still there, waiting. If you travel to a dark place far from city lights and look up on a clear, moonless night, you can still see it, that soft band of light stretching across the sky, the combined glow of billions of distant suns. It's worth seeking out, worth experiencing at least once. Not tonight, though. Tonight you can just rest and imagine it and know that it's there, even if you can't see it, a constant presence, a reminder that we're part of something much larger than ourselves. The Milky Way is not alone in having a supermassive black hole at its center. Nearly every large galaxy has one, and there's a curious relationship between the mass of the black hole and the properties of the galaxy's bulge. Larger black holes are found in galaxies with larger, more massive bulges, and this relationship holds across a wide range of galaxy types and sizes. This suggests that the growth of the black hole and the growth of the galaxy are linked, that they co-evolve, each influencing the other. How this happens is still being studied, but it's clear that supermassive black holes are not just passive residents at the centers of galaxies. They play an active role in shaping their hosts, regulating star formation, influencing the flow of gas, and contributing to the overall evolution of the galaxy. The Milky Way and Sagittarius A star are partners, in a sense, bound together by more than just gravity, their fates intertwined. It's a relationship that's existed for billions of years and will continue for billions more, a partnership on a scale we can barely fathom. There are stars in the Milky Way with strange and wonderful names: Betelgeuse, Rigel, Aldebaran, Antares, Deneb, Vega, Sirius, Procyon. These names come from Arabic, Greek, Latin, and other languages, reflecting the long history of human stargazing. Each name carries with it centuries of observation, navigation, myth-making, and wonder. Betelgeuse, for example, comes from an Arabic phrase meaning the hand of Orion, referring to its position in the constellation. Sirius, the brightest star in the night sky, comes from Greek, meaning glowing or scorching. These names are a bridge between ancient skywatchers and modern astronomers, a continuity of interest and curiosity that spans cultures and millennia. When you learn the name of a star, you're participating in that tradition, adding your own small thread to the tapestry of human connection with the cosmos. And even if you forget the names, even if they slip away as you drift towards sleep, the stars themselves remain, patient and unchanging, waiting for the next person to look up and wonder. The Milky Way will not last forever in its current form. Billions of years from now, after the merger with Andromeda, after the eventual exhaustion of gas supplies, the resulting galaxy will be a quieter, more settled place, a graveyard of sorts, filled with old stars slowly fading, no longer capable of the vibrant star formation that characterizes galaxies like the Milky Way today. But even then, even in that far future, it will still be beautiful. The stars will still shine, albeit more faintly. Planets will still orbit. And if any life remains, or if new life arises, it will find its own meaning, its own stories, its own reasons to look up and wonder at the cosmos. The Milky Way story is not over, and it won't be for a very long time. Change is not the same as ending. Transformation is not the same as loss. The galaxy will continue in new forms with new structures, and that's okay. Everything changes, and in change there is continuation. Let everything soften now. Your thoughts, your muscles, your grip on wakefulness. There are only a few more facts left, just a handful of gentle thoughts to carry you the rest of the way into sleep. You're doing so well. You've journeyed far tonight across light years and billions of years, and now it's time to rest. Let the stars watch over you. Let the galaxy hold you. Breathe slowly, drift deeply. You're safe. You're held. The Milky Way has been humanity's companion since we first looked up at the night sky. It's been a source of wonder, fear, inspiration, and curiosity. Ancient peoples saw gods and spirits in its light. Navigators used it to find their way across oceans. Poets wrote about it. Scientists studied it, revealing its true nature. And now, we know it not as a river of milk or a path for souls, but as a vast collection of stars, gas, and dark matter, a galaxy among billions, our home in the cosmos. But knowing what it is doesn't diminish the wonder. If anything, it deepens it. The Milky Way is more astonishing now than ever before, more beautiful for being understood, more meaningful for being revealed. We are part of it, made from it, held within it, and that connection is profound. You are a child of the galaxy, and it's written in every atom of your body. The stars in the Milky Way are not eternal. They live, they die, they transform. But their deaths are not meaningless. When a star dies, it returns its material to the cosmos, enriching the interstellar medium with the elements it forged in its core. Those elements become part of new clouds, new stars, new planets, and eventually, new life. This cycle of death and rebirth has been repeating for billions of years, and it will continue for billions more. You are part of that cycle. The atoms in your body were once inside stars, forged in nuclear furnaces, scattered by supernova explosions, drifting through space until they found their way to a cloud that would become our solar system, our planet, and eventually you. You are stardust, quite literally, and when your life ends, those atoms will continue, becoming part of something else, contributing to the ongoing story of the cosmos. Nothing is ever truly lost. Everything is transformed. And in that transformation, there is a kind of immortality. The Milky Way has taught us humility. When we realized that the sun was just one star among billions, that Earth was not the center of the universe, that we occupy no special place in the cosmos, it was a humbling revelation. But it was also liberating. It freed us from the burden of cosmic centrality, from the need to be the focus of creation. We are small, yes. We are brief. But we are also remarkable. We are the universe made conscious, matter that has organized itself in such a way that it can look back at the cosmos and understand it at least partially. We are the means by which the universe knows itself. And that's extraordinary. You are extraordinary simply by existing, simply by being aware, simply by lying here tonight and thinking about stars and galaxies and the vastness of space. You are a miracle, a statistical improbability, a triumph of complexity over entropy. And the Milky Way is your home, the stage on which your small, brief, beautiful life unfolds. As you drift off to sleep tonight, know that the Milky Way is still out there, turning slowly in the darkness, its spiral arms sweeping through space, its stars burning, its black holes pulling, its nebulae glowing, its planets orbiting. It doesn't stop. It doesn't rest. It continues, patient and timeless, indifferent to our worries and dreams, yet intimately connected to our existence. We are part of it, and it is part of us. And tomorrow, when you wake, it will still be there, waiting, a constant presence in a universe of change. You are held by the galaxy, cradled by gravity, supported by the structure of spacetime itself. You are safe. You are home. And you can rest now deeply and peacefully, knowing that you are part of something vast, ancient, and endlessly beautiful. Sleep well, traveler. The stars will still be shining when you wake. And so we've reached the end of our journey through the Milky Way tonight. 100 facts, 100 glimpses into the structure, history, and wonder of the galaxy we call home. I hope these thoughts have carried you gently toward rest, that the vastness of space has made your worries seem smaller, that the timelessness of the cosmos has given you permission to let go, to stop striving, to simply be. The Milky Way will be there tomorrow, and the day after, and long after we're gone. It's patient. It's constant. And in a universe that often feels chaotic and unpredictable, there's comfort in that constancy. The stars keep burning, the galaxy keeps turning, and life, wherever it exists, keeps finding ways to persist, to grow, to wonder. Thank you for spending this time with me tonight. Thank you for letting me guide you through the stars, through the spiral arms, through the dust and gas and ancient light. If you found peace in this journey, if it helped you relax or drift off to sleep, then it served its purpose. That's all I could ask for. If you'd like more of these gentle explorations, more journeys through science, space, history, and nature designed to soothe your mind and quiet your thoughts, please consider subscribing to the Sleepy Science channel. There are many more topics waiting to be explored, many more stories to tell, and I'd love to have you along for the ride. But for now, there's nothing left to do but rest. Close your eyes if you haven't already. Let your breathing slow. Let your body sink deeper into the bed. Feel the weight of the blankets, the softness of the pillow, the warmth and safety of this moment. You are exactly where you need to be. The Milky Way is vast, but you are not lost within it. You are held. You are home. And as you drift into sleep, imagine yourself floating gently among the stars, weightless and free, carried by currents of gravity and time, surrounded by the soft glow of distant suns. There's no rush, no urgency. Just the slow, patient unfolding of the universe, and you resting peacefully at its heart. Good night, sleep well, and may your dreams be filled with starlight,